Mediator is a tool that makes implementing the Mediator pattern much easier. It also allows us to conform more easily to the CQRS pattern. Now, if I've already lost you, never fear. I'm going to briefly touch on what each of those patterns is, why they're important, and when we should use them or not use them. Then we'll see an example of how to use Mediator, the tool, in our projects in C#. Now, if this is the first video you've watched of mine, my name is Tim Corey, and it's my goal to make learning C# easier. I provide videos twice a week here on YouTube to help you grow as a developer. I also have a full set of training courses on IamTimCorey.com. I encourage you to check out all the resources I have to offer. Now, in this video, as with most of my videos, I'm going to create some source code. If you would like a copy of the source code, use the link in the description below. Now, let's start off with going to the whiteboard to talk about what is Mediator, what is CQRS, and so on. So let's start off with CQRS. So CQRS stands for Command Query Responsibility Segregation. All right, which is quite the mouthful. Move that around and make it a little bigger. So that's CQRS, Command Query Responsibility Segregation. And the idea is fairly simple. So we have normal CRUD commands. You may be familiar with the acronym CRUD, which stands for Create, Read, Update, and Delete. This is how we deal with data. Well, instead of having all of our CRUD kind of together, what we're going to do instead is we're going to segment it out into two different pieces. And we're going to have our reads right here and our creates, updates, and deletes right there. Now, what does that do for us? By creating this line here, we can separately scale up this side or this side as necessary. So there are some benefits here, but there's also some added complexity in doing that. We're essentially splitting our data access into two parts. One part is all about getting data. That's this right here. The other part is all about updating data. And this is most often used in larger applications. And the reason why is because it adds complexity. However, it does give us some additional benefits. Like I said, we can change the read to scale up or move to a different server or other things like that. We can scale that up separately from our creates, updates, and deletes. They create two different systems for doing this. So there are some benefits to the command query responsibility segregation principle or pattern. So let's now move on to, let's get rid of this. Get rid of all of it. You need to go away too. There we go. So now let's talk about our second pattern today. And, whoops, there we go. That's the Mediator pattern. Now, notice how it's spelled. It's spelled Mediator like you normally spell it, not like Mediator, the tool. So yes, it's a little confusing. All right, so let's move that over here as well. We will make that a little bigger. And for all those of you who love to see things crooked, we could make it crooked too. All right, so you have the Mediator pattern as well. And the idea here is similar in nature as far as adding complexity, but also adding benefits to larger applications. And that is, normally we have this pattern where I have my front end, whether it be my API or my Razor application or Blazor or WPF, whatever it is, and it's going to talk to my, let's keep this simple here and just say business logic. And then that's going to talk to my DataAccess. Okay? And from there, we're talking to the database. All right, that's the standard pattern for an application. If you've watched any of my applications being built, this is the pattern you see. This is a very clean and simple way of building applications. You have some segmentation and separation, but at the same time, there's not a lot of complexity. Now, what we have next with Mediator is we have this idea that we kind of put some separations in here. You see, right now, there's some coupling. Now, we do have the idea of dependency injection and having interfaces, but in general, we've got coupling here where we have our front end talking to our business logic. We have coupling here where we have our business logic talking to our DataAccess. So there is some coupling. Now, with dependency injection, we reduce that or loosen that coupling by talking to interfaces. That allows us to more easily test things. However, what happens when your application scales? Well, then what happens is, especially this layer right here, we have hundreds of different classes. And each one of those has to talk to a lot of other classes because we're doing things like dry, don't repeat yourself, and conforming to solid, and so on. So you've got lots of these little classes that have to all depend on each other. And so what happens is we have this system where, let's just say we have service A. And that's going to need to depend on service B and service C and service D. Like so. So it depends on those three. And in a simple world, that's fine. So what would happen is for each of these, you would bring us in via dependency injection. Okay, so you would inject those into our A. Cool. Now what happens if we have a more complex scenario? Say we have another service, let's call this service E or class E, that needs C and it needs D. Cool, that's fine. But now we have this F over here, and that depends on B, and now E depends on F as well. So now really we've got this complexity graph going on, and maybe even we have this dependency from A to E. And before we know it, what happens is in our constructor, you've probably seen this before, in our constructor where you bring in your dependencies, which is always good to see what your dependencies are right away, you have this list of 6, 7, 8 different dependencies that you're depending on. And that can cause additional complexity. You're bringing all these things. You've already got the logger you're bringing in. You're already bringing I configuration, talk to app settings, but then you're bringing in even more things to do your work. Well, that can be additional complexity as the size of this application right here grows. So as it grows, you'll get more and more of this complexity going on. So that's where the mediator pattern comes in. So let's highlight all of this and get rid of it. We will cut that out. And here, we'll cut this out too. Okay, so let's talk about the mediator pattern. What happens there? Well, let's just say you have a class. And that's class A. And it needs to talk to class B. Well, instead of going directly from A to B and having that direct dependency, what happens instead is we have this mediator. And A says, mediator, I need something. And mediator says, okay, I know how to get that. And goes to B. Now, this may sound a little bit like dependency injection. And in some ways it is. Because what's happening is we are allowing something else to tell us what the implementation is of our dependency. But in other ways, it's a little bit different. Now, I'm not going to go too deep into the Mediator pattern, but essentially in this, we're going to have is one call and one handler. The handler fulfills the call. So the call says, this is what I need. The handler says, I can do that, and it's going to do it. And this is a one-to-one relationship. There is not a one-to-many here. We can use a more of a broadcast, kind of like an eventing system with Mediator, the tool. But for today, we're just going to talk about the one-to-one relationship call to a handler. Now you may wonder, well, how does that really solve our complexity? Haven't we just moved our complexity somewhere else? And the answer is not really. We have in some ways, but we've moved it out of the caller. We've moved it out of this location and moved it into here. So if we now have, let's just say we have over here C, and that depends on B as well. It can call into the mediator, and maybe it also depends on D. Well, C calls in the mediator again, this time asking for D. This one's for B, and it just gets the information. And D might depend on B, but it's not going to go directly. It's not going to do that. Instead, what it's going to do is it's going to go and talk to the mediator, which is going to get the B handler. So there's this central piece now called the mediator, which is going to handle all of our communication between our various systems. Now, this is all really theoretical. Let's talk about, or let's see how to implement this in a real application using the Mediator NuGet package. So let's go to Visual Studio and we'll create a new project. Now what I'm going to do is I'm going to create a Blazor server application first. So to do that, we can search through here to find Blazor server, or we can type Blazor, and they have changed again recently. I'm not as big a fan of the new changes, but now we find Blazor server separate from Blazor WebAssembly. We can select that, hit next, and from there, let's give it a name. Let's call this BlazorUI, and the project name of Mediator Demo, and hit next. We're going to use .NET 5, which is the current version as of the recording of this video. We're going to configure for HTTPS, but no authentication. We hit create. And this will create for us our sample Blazor application. We're not going to go into major modifications of this. We're just going to work with changing this, the index page, and making some tweaks here. That's all we're going to do in Blazor. So if you're not familiar with Blazor, no worries. We're just using this as a quick, ready-to-go template that we can then add things to. Next up, we're going to add another project to our solution. And this is going to be a class library project. And we'll call this let's call it DemoLibrary, it's fine. Yes, .NET 5 is what we'll use. We could use .NET Standard 2.0 or 2.1, but we're going to use .NET 5, which is the current version. That means it will only work with other .NET 5 projects. Let's delete class 1. And now what we're going to do is I'm going to add some sample data access to this demo library. Now, I debated putting actual data access in here because oftentimes people get confused when they see sample data access and wonder, well, how would I do it with SQL or with MySQL or with whatever? The data access we're going to do here, if you want to replace it with an actual data access that talks to one of those things, you just put the code in the spots in the sample data access, okay? So I'll show you how we're going to do that. We're going to say add new folder, call it data access. And in here, let's add a new class, and we're going to call this demo data access. Make it public. Now we're also going to need a models folder. I am compressing a couple of things in here. Let's call it models. And let's create a class in here called person model. Person model. And this is the data that would come from the database. Now I am going to compress a little bit some of the things you could do. You could expand them out further as your application grows. The balance I'm trying to hit here is that Mediator really should be for larger projects. It adds complexity. Let's bring up the whiteboard again real quick. And let's start by getting rid of this. And let's talk about the balance we have to hit. So if you've ever seen, there we go. If you've ever seen a teeter-totter or a seesaw or something like that, you have this idea of a beam that's balanced in the middle. And then whatever you put on the beam on one side is going to cause the beam to go down that side, which lifts the beam on the other side. Okay, that's a fairly standard playground thing that kids do. So on one side of our application, we have the size or the complexity. Okay, so how big or how complex is our application? If we have a hello world application, it's very tiny, which means there's just a little bit of force pushing down on this side of the balance beam. And because of that, we have to have on the other side to balance it out, we have to have a little bit of best practice patterns, those kind of things. Okay, so this would be the patterns. So the smaller the size of your application, roughly, the smaller size of, and the less complex your application is, the smaller you want your patterns and things you apply to your application. Things like dependency injection and even dry. The smaller your application is, the less you worry about that. Now, as your application gets bigger, so now we're pushing down harder on this side, you need to have a correspondingly larger amount of patterns and design principles going into balancing out your application. Because the ideal here is that we have this line right here be equal. Okay, so that we've got the same, we don't have the balance beam look like this, where we have it, unbalanced. We don't want an unbalanced application. Instead, what we want is this concept of the larger and more complex our application gets, the more we apply patterns and systems to make our application easy to maintain and easy to manage. But that ease is relative to the size. Okay? If you apply, let's just say, take for instance, if you had a small command line operation that said hello world. If you follow conventional wisdom, where you say, okay, dependency injection is good and solid is good, and making sure that we're dry and having interfaces, not implementations, and all this, and even unit testing, applying all that to a hello world console application will give you about 200 lines of C# code for one line of actual work. That's ridiculous. That is unbalanced. So what you want to do is maintain the balance based upon the size and complexity of your application. All right? So that's what we're looking at doing here. That's why I say Mediator and CQRS is not for every application. It's going to be for larger applications. So what does that mean for this application? Well, I'm trying to build a small application in order to show you just the Mediator tool. But that means it's really too small to warrant having Mediator and CQRS implemented in it. So there's going to be a little bit of a go with me here. There's going to be a little bit of a saying this is what it's going to look like in its barest form, but in a larger application, you will see how it would be beneficial. Okay, so just note we're going to do just a little bit of work here, just a little bit to show you what the CQRS pattern looks like and how Mediator can make our lives easier, but it will grow over time in a real application. So back to our person model, we're going to put 3 properties in here: ID, first name, last name. Okay, those are the 3 properties we're going to put into this person model. Again, in our demo data access, we're not actually going to go to a database to get this. Instead, what we're going to do is we're going to actually have right in here, private list of person model, which that adds a using statement, by the way, for person model. Person model people equals new list of person model. Actually, I can just say new. That's the new C#9 syntax, which allows us to not repeat saying this, just to instantiate something. Now in our constructor, I'm going to say people.add new person model, and we'll say ID equals 1, first name equals Tim, last name equals Corey, and put a semicolon at the end. Let's shrink it down so you can see it. And we'll do this one more time, and we'll have my ever-present helper, Sue Storm. Okay, and now we have our data access set up. We're going to have 2 methods in here: public list of person model, and that's going to be get people. It's going to return people. And then we'll have a insert method here, public person model, insert person, string first name, string last name. And in here we'll say person model P equals new. Autocomplete is going to do that for me, but I'll just do it like that. And then say first name equals first name, last name equals last name. I'll explain this in just a minute. So what we're doing here is, remember I said that if you want real data access, you just need to replace the methods here. So this get people, we're just returning our list from up here. But instead what we could do is you could say, well, actually go out to the database right here, get that list of people, convert it back, and send it back as a list of person model. That's just a Dapper call. If you're using Dapper in SQL, that's just a Dapper call. You've seen it in others of my videos. Look at the Timco Retail Manager, for example, to see an example of that, where you just replace this with a call out to Dapper to say, hey, load this store procedure or load this table and return the values. Same thing here. The insert, we'd actually insert this in the database. But instead what we're going to do is we're going to add it to this people list. Now the only kind of tricky bit here is I need an ID that I want to actually have a real unique ID. So p.id is going to equal people.max, and we'll say x arrow x.id. That's going to get the max ID already in our list, and we're going to add 1 to it. Really simple stuff here. And then we're going to say people.add p. That's going to add our new person to the list. That's our insert. But we have this return. And the reason we have the return is because we want to see what the data is we inserted, including what the new ID is. So we'll just return p. That's it. So that's our insert method. And that's our complete demo data access class. All we're doing is 2 things: getting people and inserting person. That's it. What we'll do is we'll create an interface. So control dot on my class name and say extract interface. And the only thing I'll do here is I'll change this from iDemoDataAccess to iDataAccess. That way, if you want, you can change and create a new DataAccess that does the real job. So we're all set with our setup stuff before we get to Mediator. So let's go back to our BlazorUI and let's talk about what we're going to do. In the index page, we're going to put right in here, let's actually create a code section. Code. And in here, we'll say protected override. And that's going to be the on-initialized async, which of course is going to mess up my formatting. No big deal. We'll just fix the formatting. And in here, we're going to do some type of work. We're going to say, I want to get information. In fact, what information you want, let's define it already. So let's create a dependency, a project reference dependency to our demo library. And now we can say, I want to have access to, and we'll go to this models folder here and say person model. I want a list of person model, which of course spells the whole thing out. List of person model called people. And we will initialize that in this uninitialized async. But we don't know how to get this yet. So first, let's cut this out and we'll put it in the imports.razor. We'll paste it in. Now, if I'm losing a little bit with this Blazor stuff, I do have videos introing Blazor itself. The keys here are, I just add a using statement there. And this is going to get called essentially at the beginning of when the page loads. There's some more nuance there. You can watch my Blazor videos for more on that, but essentially that's what it's going to do. So we're going to load somehow get list of people. Okay, there. Now, let's just get that to go away. That writes quickly. So now in here, we're going to create an unordered list. Now, if you're not familiar with HTML, that's essentially a bullet point list. And we'll say at for each. And we'll say var p in people. And we'll have a list item where we'll say at p.firstname space at p.lastname. And we'll have a list of all of our people we've loaded. That's just going to show us right now, Tim, Corey, and Sue Storm. Okay? That's a theory, but we haven't yet loaded this list of people. So how do we load this list of people? Well, let's start by setting up our demo library to use Mediator. So in our demo library, we're going to, let's close these out. We're going to right click on our dependencies and say manage NuGet package. And we'll search for Mediator. I spell it right. Okay, notice there's no O in it. That's not a misspelling. That's how it was designed, Mediator. So we just want the bare Mediator, which currently is at 9.0. We install that. And now we've set up our NuGet package. Now let's actually build out a Mediator setup. Now remember that I said that the CQRS pattern is supported by and encouraged by Mediator. And in fact, it's fully compliant with it. So let's create folders for those items. We have first our queries. These are the things that we're reading. These are our read commands. Remember that CQRS splits up reads and writes? So the other side of it is a folder we'll create called commands. That is the writes, the things that we're going to insert into the database. And then we have, finally, we have our handlers. So what's going to happen is we're going to say, I have a query I want run. And in fact, let's create one. So we're going to say add new class, and we'll call this our getPersonListQuery. Okay, I'm calling it query at the end. That's a naming convention just to let me know that, yes, this is what it's for, is a query or a command. That's more specific to the CQRS. Now, I'm going to change this. Instead of being a class, I'm actually going to take it off and change it to a record. Now, if you're not familiar with records, I did cover that in a previous video. I have a video all about records and what they're used for. So records are just like classes. In fact, they are classes, except that they've got some additional syntax goodness. And part of that is you create them once, and then in theory, they are unchangeable, meaning they're almost read-only. Now I say almost because there are things you can do to forcibly read write, but you shouldn't. So let's get rid of this and we'll say public record. Now a record gets declared in a couple different ways. We could specify every property with an init for our set, but instead we can just use our open and close parens and say, these are the values inside here that are going to be my properties. But in our case, since we're asking for all the people, there is no data we have to pass in. So I'm just going to give it an empty record, meaning it has no properties. It just has essentially a name. And then I'm going to say this implements I request. Control dot there to add using Mediator. And then this is going to be what it returns. This is our out or our response. So I'm going to say, well, it's going to return a list of person model. Control dot again to add that using statement as well. And at the very end, we need a semicolon. So this is our record, and this is what it implements, this interface, which just says, here's what I'll return. Now, if you want to do a class instead of a record, not a problem. Let's type it out here. Public class, let's call this get person list query class. Just so you can see it. Oops. There we go. And then in here, we'd have no methods, but I would still do the same interface like so. Okay, so this and this are equivalent, except the fact that a record has the additional syntax and goodness that records provide, such as being immutable by default and so on. So that's the comparison there. I'll leave that commented out there just so you can see the comparison in case this syntax right here confuses you. All right, so make sure that you understand what's going on. All right, so that's our get person list query. This is the data we're passing in. It's also how we'll identify what the handler is. And that's where we start talking about the handler. So we'll wire this up in a minute so you can see it called through. But every query will have one handler, not more than one, just one. So under handlers, let's create a class. And let's call this the get person list handler. And in here, we'll make this still a class. We're not going to change it to record. Public class get person list handler. Implement I request handler. That's going to add the using up here for Mediator. And then we have to pass in two generics. Well, potentially two. You can pass in just one, but in our case, we have a return value. So we have the get person list query we pass in. This is what you're going to handle. Well, you're going to handle the get person list query. But if you have an output, you're going to output that value. So list of person model. That's going to add a using statement for that as well. So notice up here, my usings are probably a little different than yours if you didn't have that auto add. All right, so this I request handler, which is different than I request. The I request is for your queries and your commands. But then on the other end, when you're going to handle that query or that command, you pass in first which one you're handling, and then optionally you pass in, you say what the output is going to be. In our case, the output is going to be a list of person model. So that's our iRequest handler. Notice it's yelling at us because we have not yet implemented it. Well, if we implement this interface, it's going to add one thing, a handle method. That's it. And now note, let's unpin this, that the handle method, you pass in your request, which is a getPersonList query. That's any data you need for the request. We also have this cancellation token because everything is asynchronous in Mediator. So that's really nice because it just makes life easier. But you can pass in optionally that cancellation token. And then the return is going to be a task because it is asynchronous of type list of person model. That's our output we expect. All right. So that's all we have to implement for this iRequest handler. So let's implement this. We first need to have a constructor, CTOR, where we need to pass in our DataAccess. And we'll call this data. And we'll do a control dot to create and initialize the field underscore data. And you may say, well, Tim, where is that coming from? Well, this is dependency injection. So we're going to have dependency injection inject into this an DataAccess. Mediator does not replace dependency injection. It just adds to it or improves it. So we can still use dependency injection to get the final details we need. In this case, in our handler, we need to know about our DataAccess layer. So we can say in here now, return task.fromResult. Now this is kind of I don't want to call it a cheat because it's not a cheat necessarily. But what we're doing is we have a synchronous call, not an asynchronous call. And yet we need to return an async value, something we can await. And so you say task.fromResult to pass in your synchronous result, and that will turn it into an asynchronous call. It's not actually putting on a different thread. It's not doing anything like that. It's just saying it's wrapping our result in a task. That's all it's doing, and it's a completed task. So it's complete right away. It's just a little bit of syntax sugar here to help us properly return a task. So in here we say underscore data dot get people. And that get people method is going to get that list of people. We'll return that in our handler. So now our handler knows about our DataAccess. But that'll be the only place that knows about DataAccess is our handlers. All right, so we have our handler, we have our query. Let's go back to Solution Explorer. We'll pin this back on. And we're pretty much done in our demo library for our first take at or first use of Mediator. So let's go back over to our BlazorUI. And the first thing I do is configure startup. You need to bring in that DataAccess. So services.add singleton. Now, normally when we have data being stored, I would not use a singleton because a singleton means that everyone has access to that data. It's not going to be refreshed throughout the life of our application. That can be really bad for a web application because when I load it, it'll be the same as when you load it. But in the case of a demo like this, it's perfect because I can actually have my data persist. So add singleton for DataAccess. That'll add the using statement. And demo DataAccess. That's going to map those two. And notice up here we have our added using statement for DemoLibrary.DataAccess. So that adds our DataAccess to our dependency injection, but we still need to add Mediator and all the things in DemoLibrary. Now, this is where things get a little interesting. Is for Mediator, you can say services.add Mediator which I have not installed Mediator yet. So that's why it's not even coming up. Well, let's do that. Right-click on dependencies for our UI and say Manage NuGet Package. And we're going to search for Mediator. And instead of this main one, I want to include this one instead, mediator.extensions.microsoft.dependency-injection. This will allow Mediator to work in our .NET Core dependency injection system easily. Now, this is going to install the base Mediator package as well. So let's install that, accept the terms. Once that installs, then we can come back over here add Mediator. Now, for adding Mediator, we're going to say type of to get an assembly. But this can be a little confusing because you have to grab a class in here. For example, I could grab the getPersonList handler, or I could grab the model here, or I could grab even DataAccess. So I could say demo DataAccess and then say .assembly. Okay? That's not going to load just demo DataAccess. That's going to load the entire assembly and look for anything to do with Mediator, which is going to be anything that is a handler, a query, or a command. At least in our example. There are other things that Mediator will look for. Now, if they were in the same project you are, typically what people do is they say startup, which is the class you're in. But that would be this BlazorUI, and that's not where our Mediator stuff is. We have it in the demo library. So what you can do, this is questionable if it's a best practice or not, but it makes it easier to read. If you can create in the root of your demo library a class and call it startup, or you can call it something else. You could call it Mediator entry point or demo library Mediator entry point. It's up to you. In fact, let's do that. Let's call it demo library Mediator entry point. That is really clear what it is. We'll hit Control Dot to rename the file. And now we have this file in there. We can grab this, copy it, and go back here and we'll paste that in. We have to do a Control Dot to add a using statement. But now we know this demo library Mediator entry point is for the demo library. So it's very clear what we're adding to our Mediator. All right, but again, that's not adding that class, it's adding the entire assembly. So now Mediator has been added to our dependency injection system along with DataAccess because that's necessary for the handler. Now we can go over, we can save this. We can go over to our page, our index page, where we're already set up to call our Mediator. So you first have to inject something. Now remember I said that as your complexities grow, your list of dependencies you inject into any given item or class is going to grow. Well, with Mediator, that shrinks right back down to 1. Inject Mediator dot iMediator. Like so. And we'll call this, let's call this Mediator. If I let's do underscore. Like so. And now we can use this Mediator to find what we need. Now, we also should go to our import statement and add some usings here. We have the models already. Demo library dot handlers. Demo library dot, let's just copy that so it's a little bit faster. Dot queries. And that's all we have actually for now. We're going to have commands soon, but we don't have them yet. All right, so that's going to make our life a little easier when it comes to doing these calls here. Let's get rid of this throw exception. the comment, and let's put our code in there to talk to Mediator. We'll say people, that's where we're going to assign it to, equals await Mediator. Whoops, we have to say override async. Mediator dot send. Now, the send command is the only command you really need using this pattern of having a command or a query and a handler. You just say send new get person list query. Okay, so I've said, hey, this is the query I'm going to do, which has all the data in it, which is nothing. I want you to send that. That's it. And the result is going to be, if you look here, it's going to be a list of person model. Actually, it's going to be a task of list of person model, which is why we're waiting it. We await it, therefore people will get populated with a list of person model. Now, I'm going to run this, we're going to see it, and then we're going to talk about it. So let's do that in that order. Let's run this. Get this to go. Hopefully nothing breaks. There's our index page, and as you can see, hello, your new app, Tim, Corey, and Sue Storm are on the list. Well, how did that work? Because really, that's a pretty simple command. Well, Mediator said, I've got a new send request. You're sending out a request, and the request is of type, or the data is of type get person list query. So it says who handles that. And if you go to the handlers here, you'll see that the get person list handler, which I've conveniently named to correspond, but this handler handles get person list query. So it says, okay, you've asked for a get person list query. I've got the handler for that. And by the way, it returns list of person model, so you can know what it's returning. And it says, okay, call the handle method, do that work, return the values, and boom, you're done. So when it comes to our actual index page or whatever page we are in Blazor, the call to get data is that right there. That's it. Now, our handler is quite small. It's only doing that right there. When in fact, it could be doing a lot more than that. But let's just say it is, 5, 10, 15 lines of logic. We just have one line in our actual UI that just says, hey, handle that. We've moved the complexity. We haven't gotten rid of it entirely. In fact, we've added some complexity, but we have moved it out of our user interface. What are the benefits of having this set up like this? Well, our page here, there's no real logic. The logic is just do something, go do it, and then display the values. If we get values off this page, we just say, go use those. That would be all we would do. So there's not a lot of work going on here. Instead, the work happens in the handlers. But notice the handlers are just simple methods that we could pass in, we could instantiate this class without Mediator, which is the point, because now we can use unit testing to test this handle method. We can inject DataAccess, and we can test just the handle method for this, and it's very simple. Let's make this even more obvious how this can be helpful. Let's close all the tabs here. I am going to minimize everything here. I'm going to right-click on solution and say add. We're going to add a new project type. Let's create an API project. So let's search API. We have ASP.NET Core Web API. That's the one we want, not framework, core. Hit next, and we'll call this we have BlazorUI, so let's call this our API, or call it DemoAPI. There we go. DemoAPI Our naming conventions all over the place. It's okay, it's a demo. .NET 5, yes. No authentication, yes. Configuration for HTTPS, yes. No Docker, and yes to Open API support. That'll give us Swagger, which is very helpful for this demo. So basically all the defaults, we close this down, right-click in dependencies and say Manage NuGet Packages, browse for Mediator, install the mediator.extensions.microsoft.dependency injection, hit I accept, and now we have Mediator installed in our API. Now what we're going to do is let's go back to our BlazorUI and go to Startup. I want to grab these two lines, just instead of retyping them. I'm going to grab them and go to our Startup. And after the Swagger gen, I'll paste those two lines. I have to add let's add the dependency. So right click on dependencies and say project reference. Reference the library, demo library, not the UI. And now we can say control dot to add the using statements here that we need. And that adds our various using statements. If you look up here, there's our new using statements for DemoLibrary, DemoLibrary.DataAccess, and Mediator. Save those. We now have Mediator implemented in this API, just with these two lines and the NuGet package. Now, let's go to controllers. We can right-click on controllers and say Add New Controller. And we're going to choose an API controller. Sorry, it's a little small. I'm not sure why they're that small. We're going to choose API controller with read-write actions. Now, it's going to give us a demo to work from, which is just easier in my opinion. Hit Add. And we're going to call this the person controller. Okay, and this is going to scaffold out for us a number of commands. In fact, all the general ones. So we have our get, which is usually a list. We have our GetById, which is usually one item. We have our post, which is kind of like an insert. We have our put, which is an update, and then we have our delete. Let's get rid of the put and delete and just have our get, our GetById, and our post or insert. So let's talk about bringing in Mediator. Well, CTOR to create a constructor. We're going to say we want the I Mediator. It's going to add the using statement for Mediator up at the top. And we'll say Mediator, control dot to create and assign the field for Mediator, which adds that right there and that right there. And now in our get command, we can say this is a async task of type list of person model. That'll add the using statement we need. So it's an async task of person model. And in here, we're going to say, just like in our Blazor app, we can say underscore mediator dot send. Oops, we need to await this. Await mediator dot send. We can pass in here a new get person list query. Okay, that's it. So now with just a few lines of code, if we switch over to this API as the startup project, so right click on it and say set as startup project, we run this. This will start our API, which will start Swagger, which is really helpful because now I can say under the get for person, try it out, execute, and you'll see here that we have under the body the response, Tim Corey and Sue Storm, IDs number 1 and 2. So we're working, we have a get command working in the API the same way we have it working in Blazor with just a couple of lines of code. And that's kind of the the awesomeness here is that because we're using Mediator to load that entire assembly, and because we are just saying, hey, call that query, we don't have to think about the implementation details in our user interface. And so when you talk about really thin API controllers, the idea they're tiny, they do practically nothing. This right here is the definition of practically nothing. It's saying, I don't do anything. I just tell somebody else to do something. That's it. So let's kind of flesh this out. We'll do it on the API side. It's a little easier, a little faster than trying to do it on the Blazor side, because I don't want to go into how to create edit forms and all the rest in Blazor. Let's just do it right in the API because it's fairly simple. So let's implement this right here, which is just get one, and we'll base it upon the ID. So what do we need for that? Well, let's go back to our demo library. Let's close all tabs. Otherwise, it will open back up if I select one of those tabs. So let's go to our queries. Because it's a query, we're just asking for data. A query should not modify data, okay? It's a read action. In fact, it can be read only. So let's go to queries and we'll say add new class, and we'll call this the GetPersonById query. And again, we'll make this into I'm gonna make this public, and I'll say this will be our demo, just as comparison. But I'm gonna do the public record GetPersonById query, which takes in an ID. And we'll say I request, and it's gonna return person model. So that's our entire query right there. We're just saying we have an ID in this person by ID query. Now the class equivalent of this would be to have a property like so, and maybe even to create a constructor that required it. So let me say that, ID equals ID like so. And then we'd also implement the I request. Okay, so that's the equivalent right there. But why write, whatever, 8 lines of code when you can write one really clean one? I'm not big for just shrinking down code to shrink down code, but this right here is just so clean. So there's our record. So we have our query. Now let's create our handler. We right click, we say add class, and we're going to say this is the GetPersonById handler. Public. And this is going to be an I request handler of type GetPersonById query. This is where you can get tripped up a little bit. So if I said GetPersonById handler, then it's going to let you put that in there, but it's going to yell at me. So, and then person model. All right. And I have to implement this now, control dot to implement the interface. So just to go back to this, if I put this here instead, it's going to yell at me and say that the GetPersonById handler does not implement interface member I request handler. And you're saying, wait, what's going on here? This is kind of a looping thing. Well, actually, sorry. There we go. That's what it create. But this right here is where it says cannot be used as a type parameter. All right. So that's where we go, what's going on? Why is it yelling at me like this? And there's no implicit reference conversion from GetPersonById handler to person model for I request. So that's because we're using handler here, which is right here. We're trying to implement it and also use it as a parameter. So just note that needs to be a query or a command. So check that if you have an error. So we'll do the undos here. Whoops, there we go. So it needs a query or a command in this spot, not a handler. If you have an error, check that first. Now, in here, I could do a separate call for my DataAccess, except for the fact that my DataAccess doesn't have a lookup that gives me just an ID. But I do know that I have another mediator object that can give me a whole list. And then I can query that list for just one ID. Now, if you have a database and you have a give me an entire list, and you have another command that's going to give you a record by ID, probably you want to go back to the database because the database is more efficient than your lookup for everything and then just filtering by one item. But in our case, I want to show you the concept of a mediator item, a handler, calling another mediator. So let's do this. Let's bring in first our mediator. So CTOR constructor. And then in here, we'll say iMediator, which is going to add the using statement. If it doesn't have it already, I think we already have it for mediator. So iMediator, we'll call it mediator control dot to create and assign that field. And now down in here, let's make this async. And we'll say, I want, say, var results equal to await underscore, if I can type it right, mediator dot send new get person list query. So give me all the people. That's what I want. I'm going to await that so that the results will be a list of person model. And now I can say var output equals results dot first or default for x arrow x dot id equals request dot id. Now where'd that request dot id come from? That comes from right here where you passed in that data. So you've queried it and said, this is the ID I want. And I say, okay, find the first or default in the entire list. Find the first or default where the ID matches the ID you've passed in. So if you pass in a 1 or a 2, it's going to find the corresponding value, either Tim or Sue. If you pass in a 3, it's going to say or default, which is a null. And there'll be a null in here. And then we can say return output, which is the resulting value, either a null or a person model. Now, we're not going to get into error handling in this demo. Again, we're keeping it really tight to just mediator stuff. But now I just wrote another handler. This one is going to be for handling looking up just one element. Let's go back to our API, changing nothing else. Go to person controller. Let's scroll down here to GetById. And this is going to look practically the same as line 29. We're going to return await underscore mediator dot send new get person by ID query this time. We'll pass in our ID. And I'm tempted to put a default value there for some reason. I'm not sure why. That's it. So the ID that you pass in for your lookup, we're going to pass that into the get person by ID query. We're going to send that out to mediator and say, hey, give us the handler, or call the handler, give us the results the handler gets, and return that. We're going to wait for that. Now, it's yelling at me because this should be not string. It should be async task of type person model. That's our lookup. All right. So that's what's going to return is a task of person model. We're going to await that. So now with this in place, we can run this again. And this time we'll be able to do a lookup based upon our ID. So we have the person. We can do the try it out, execute, and we get the 2 results, Tim and Sue. Then down here we have get person by ID. We can say try it out. We change this to be 2, execute, and the result is we get back Sue Storm. Now, if we say 3 here and execute, we'll get back a 204, basically a null. Okay, so we haven't gotten any data back for that. We could have handled that. We're not going to. Pass into 1 here and get back Tim Corey. Okay, so now we've got these two wired up. We've got the get person and the get person by ID. Ignore weather forecast. Let's do the post now. Let's set this up so we can send in data. So let's close this out. Let's go back to our demo library, but we're not going to create a query because remember, a query is for reads. We want to create a command. So right click, add. This is going to do an insert into our database, which in this case is just a static list. So let's call this insert person command, which I'm going to create that, again, that demo for you, public class with class at the end. And we're going to say that we have string first name, string last name, and we'll create a constructor as well that we pass in those values. So string first name, string last name, and then say that first name equals first name and last name equals last name. Okay, that's essentially what we're going to do. And then it would implement the I request, and it's going to return back a person model. Okay, so and I add a using statement for that as well. So those are 2 usings that have been added. So that's the code we could create if we create a class. But let's comment this out. We do want to comment it out because we would otherwise have another command, but this time it would have no handler. So you do want to comment it out. Public record insert person command that takes in a string first name, string last name. And if you're not familiar with, let's do this first. I request person model. And notice how it's and a semicolon. Notice how it even kind of reads like a command where it says, okay, here's the command. I request a person model. That's what I want to return. So if you're not familiar with records, the fact that we are capitalizing first name and last name may seem a bit odd because down here we have a lowercase first name and last name because that's what a parameter typically is. These aren't traditional parameters. They're actually going to create properties based upon these names. So therefore, we capitalize them because the properties should be a Pascal case, not a camel case. So again, watch my records video if you want more in depth on that. So again, that one line is our command. So we're going to pass in a first name and last name. We're going to get back a whole person model. I want to get that whole person model back so I can see what was inserted in the database, including the new ID. So let's talk about creating a handler for it. Now, handlers are all going to the same spot. So whether they're commands or whether they're queries, they all have this one handler spot. So we add a class for handler, and let's call this handler the insert person handler. And I'll make this public. And at the end of this, we'll say, I request handler insert person command, and the return is going to be person model. And again, it's adding using statements for both of those. Now we can do the control dot to implement that interface. And we do have to bring in DataAccess here because we are going to be calling that directly. So CTOR, where we ask for the DataAccess, call it data, control dot to create and assign that field. And now we've talked to our dependency injection, got our DataAccess, and down here we can do our code to to call DataAccess, which is pretty simple. We're going to return task.fromResult. Again, that's kind of that cheat. We're going to say data.insertPerson request.firstName request.lastName. So I'm doing an insert person. I'm pulling the first name and last name from that command because that command has those two values. That's it, right? Because I'm returning that because insert person returns the full person model. Handler is done. So let's go back over to our controller. Our controller, we have this post here, which right now we're getting the string value. Let's just get for simplicity's sake, we'll say person model and we'll say value. So yes, you probably have a separate model for this that had just the first name and last name, not the ID as well. We'll just leave the ID blank. And we'll say var model equals new insert person command, where we pass in value.firstName and value.lastName. So those two values are going to pass into our model. That's our insert person command. Now we can say return await mediator.send our model. Because our model is that insert person command. I just didn't in one line do it. I could have said this right here, put that in our send and do it in one line. So I'll show you. If I copy this, I paste it in here, I can comment that out, and now it's in one line. And yeah, it's yelling at me. Why is it yelling at me? Probably put an extra semicolon or something. Oh, no, it's yelling at me because I have a return await, which this is a void. So task of type person model. So there we go. That should, async task of type person model. There we go. So we have either the one-liner value, which can get a little bit long, or you could replace the send value right here with model and then do it in 2 lines. It's up to you. But with that, we run this one more time. And now we have let's just get the list of people. So you have it, try it out, execute. And we have our, sure enough, 1 and 2, Tim and Sue. Go to post, try it out. And we have this little JSON byte. Again, ID is there, but we can ignore it, leave it alone. And let's just say Bob Smith. Execute. The result is ID of 3, Bob Smith. That's what was returned because that's what we inserted was Bob Smith. The ID that got generated was 3. Now if we said Mary Mutton and execute, ID is 4 and Mary Mutton. Let's go back up to the get person, get the whole list, execute this. You'll see now we have 4 entries in our quote unquote database. We have Tim, Sue, Bob, and Mary. And that's because we're using that singleton to kind of game the system into remembering between calls all the data that we've changed. And that's using Mediator. So let's kind of go over what we've seen here. The kind of broad picture context here is that in Mediator itself, the tool, we have the concepts of commands, handlers, and queries. Now, we haven't talked about that kind of the more eventing style of system. We'll probably cover that in another video. But for this pattern that we're using with CQRS, we have our commands, handlers, and queries. A query is just the data that you're sending in. And the same with the command. It's just the data you're sending in. And the handler says, I'll handle one of those queries. And this one is handling the get person by ID query. And so it does one job. It handles one query or one command. That's all there is to Mediator, because then Mediator will scan your system, your assembly, for all of the entries that say I request handler or I request. It's going to scan all of those and put them into the registration system. And it happens once at the beginning. It's very quick. And then from then on, whenever you want to make a call, instead of asking for all these different dependencies you might need, you have just one dependency. It's on iMediator. And then from there, you just say send and give it which query or command you want. That gets executed and your data gets returned. So if you notice, I have a fairly complete API controller right here. And yet really the actual lines of code for calling all the database and getting the data, searching through it for the ID lookup and returning back the values after creating a new ID and all that kind of stuff. All that work is in this line, and in this case, these two lines, because I didn't want to make it into a one-liner. That's it. So our controller is tiny. It's very, very small. In fact, this can be shrunk down even further into an arrow function, something like this, where we say, and then just have our await, like so, and that'd be it. Okay, so that could be one endpoint, the insert or GetById. We have the same thing for all of these, where it's just one line for each of our gets, posts, puts, deletes, patches. All of those things can be done with one line because the work is not being done in the controller. This means the controller in a lot of ways doesn't need to be even tested. And you can argue with that if you want. But what happens instead is you can test those handlers. That's where the actual work is being done. So I'll undo that just so it doesn't confuse you. Actually, I don't know how far it went. So there we go. So that's all you need to do in order to keep your controllers very tiny. But at the same time, if we look over in our Blazor, it's no different. Because in our Blazor and our pages, when we said, hey, I need a list of people, I have this one line and I can start using it. If we had an edit form here, the code for the result of the edit form is just pass this data in. That'd be it. So a lot of stuff you can do is shift your responsibilities out of your user interface and down into a more testable location that is also then portable. If you notice, I swapped over from Blazor to our API and didn't really have any changes. I just pulled my library. That's it. I said, hey, come along with me. Let's bring your handlers, your commands, your queries, and now I can use it in a different user interface. So some pretty powerful stuff here, but at the same time, notice that even for this little demo, I've got a lot of stuff in my class library. So again, this is where if you're doing a Hello World project, do not use Mediator. Where the tipping point is going to be based upon how big and complex your application is getting. As it starts to add complexity, that's when Mediator will start to have more benefit than drawback. And that's kind of that balance, that balance you want to hit on the teeter-totter of how big and complex your application is getting versus how much these patterns will help you. Now note also, I just did one folder for commands, one for handlers, and one for queries, and even one for model. So for commands, handlers, and queries, I might even break it down even further and say, well, for people, I have commands, handlers, and queries. And then a different one for another, roughly a table of data. And so we have multiple of these sets of commands, queries, and handlers. Again, that's as your application grows in complexity, that's when you need to start thinking about how to best keep things together in a way that's logical, so you're not hunting all over the system for implementations, but at the same time is not overwhelming with a number of folders you have to look into for your various things. Okay, so that's the Mediator pattern. I would encourage you in a lot of ways not to use it until you grow to a certain size. Don't just use this on every application you build. It's a shotgun for what sometimes is a tiny little problem. It's just way too big a solution. But for when you get bigger, this is a great solution to help you make things more testable, help you disconnect things that have it more loosely coupled. It even helps with the idea that your dependency injection is injecting so many things. Your classes have to know about so many different things. It reduces or eliminates that by just allowing you to depend on Mediator and having your handlers do all the rest. Okay, so that is the Mediator system, which uses CQRS pattern and also the Mediator pattern. I hope you've enjoyed it. If you have questions, let me know down in the comments. I'm sure there's a lot more we can go into with this. There's a lot more complexity we can dive into, but I try to keep this as high level and as entry level as possible for this intro video. If you want to see me cover something else about Mediator or these patterns, let me know down in the comments. I appreciate you watching. Thanks as always, and as always, I am Tim Corey.